All right, today we're going to talk about vectors, what they are, how to find the magnitude, and so on and so forth. First, let's talk about what a vector is. The definition of a vector is a quantity that has both magnitude and direction. So it has two parts, magnitude and direction. Now, this says magnitude is the side, magnitude is the length of your vector. Okay, so magnitude is the size or length of your vector. And then, of course, there's also direction. Vectors are used a lot in physics in that they tell you the velocity of certain things, like the velocity or the speed of an aircraft, and the direction, of course. So that's why a vector would be important. In your textbook, most of this information is going to be found in section 9.4 and beyond. So if you need to look, go ahead and read through section 9.4, and that'll give you a lot of the information we'll be covering in these sections. All right, so let's remember, a vector is a quantity that has magnitude and direction. Magnitude is the length of your vector, okay? So, a geometrical representation of a vector is what we would call a directed line segment. Okay, this is what a vector looks like. Okay, it looks like a ray. You have an endpoint and then it extends forever in the other direction, but it's pointing toward another point. So P is what we're going to call your initial point. So P right here is the initial point. And then do you see how it's starting at P and it is extending toward Q, and there's an arrow pointing toward Q. Q is going to be your terminal point. So starts at P, your initial point, and ends pointing toward Q, which is your terminal point. Just like when we were talking about the unit circle and we were talking about angles on a unit circle, we have an initial side that's on the positive x-axis, and then the terminal side is where the angle ends. We now have an initial and a terminal point. Okay, so again, a vector is a directed line segment. P, which is your endpoint right here, is your initial point, also called the tail, and Q is your terminal point, or called the tip. Okay, vectors are denoted by an arrow. It looks exactly like your vector. Okay, it's got a line with one arrow, which tells the direction of the vector. Also, it tells us vector PQ can be named PQ. You can't hardly see this, but there's a little arrow there. It can also be little p with the arrow, or you could have little p that's in boldface. Okay, all of those denote a vector. Okay, so you'd have P to Q with the arrow above it, just P, which is the name of the vector with an arrow above it, or we can take the name of the vector P and put it in boldface, and that would show a vector. Now, magnitude, again, remember, is the length of a vector. The length of a vector can be found by simply using the distance formula. Okay, so given a vector V, this is vector V, see how it's in boldface? It has an initial point, x1, y1, and a terminal point, x2, y2. We want to find the magnitude. Remember, the magnitude is the length of the vector. Anytime you're finding magnitude, it's denoted by the name of the vector with parallel lines on each side. So you got parallel lines here and parallel lines here. Parallel vertical lines at that. So if I were finding the magnitude of vector G, I would have two parallel lines and then the name of the vector. Okay, parallel, G, parallel. If I were finding the magnitude of vector AB, okay, I would have the name of the vector here and parallel lines on each side. Okay, so when you see those two sets of vertical parallel lines, you know that you're talking about magnitude, which again is the length of your vector. You can find magnitude by using the distance formula. x2 minus x1 squared plus y2 minus y1 squared. Take the whole thing and find the square root, and that'll give you your magnitude. All right, so let's go over a few properties. Okay, magnitude, once again, for the 100th time, is the length of your vector. Magnitude is always going to be greater than or equal to 0. that should make sense because we're just taking our subtraction and squaring it, therefore making it positive on both of these and adding them together. You can't have a negative under a radical without making an imaginary unit, so it should make sense that your magnitude should be greater than or equal to 0. The magnitude of a negative vector is equal to the magnitude of the positive. If you have a scalar multiplied to your vector, you can take the absolute value of your scalar and multiply it to the magnitude. All right, so those are just some properties for vectors. You will actually find those in section 9.4 in your textbook if you look over it. Let's go ahead and find the magnitude of a vector. Here we have vector AB. You can see the little arrow here going toward this direction, so that tells me that A is my initial point and B is my terminal point. The initial point should come first, the terminal point should come second when the arrow is pointed to the right. Okay, so notice I did x and x, -7 minus 8, and then I squared it, plus my y, -2 minus -4, and I squared it. -7 minus 8 is -15 squared. -2 minus a -4 is -2 plus 4, which is 2 squared. So that'll give me 225 plus 4, which is 229. So the magnitude of vector AB, or the length of vector AB, is the square root of 229. Okay, now on these magnitude problems, go ahead and leave them in their radical form. Simplify it if you can simplify it. Only change it into a decimal if it asks for a decimal. Okay, now let's turn the page. I'm going to let you do numbers 2, 3, and 4. Now if you look at the bottom, it says a zero vector. A zero vector is a vector that has a magnitude of, guess what? 0. So a zero vector is a vector that has a magnitude of 0. All right, on our next page, we are going to be talking about parallel vectors, equivalent or equal vectors, and opposite vectors. All right, let's start with parallel vectors. Parallel vectors are going to have the same direction or the opposite direction, but they do not necessarily have to have the same magnitude, so they can be different lengths, okay? But if you'll notice, I have vector A and vector B. They are going in the opposite direction of one another, aren't they? They're not the same size. You can clearly see that vector B is longer than vector A, but they are parallel. So I can say that vector A is parallel to vector B. One way to figure this out, if they are parallel, is to find the slope from the 2 points, from the initial and the terminal point. Remember, parallel lines, and in this case parallel vectors, have the same slope. Okay? Equivalent vectors have the same magnitude and the same direction. You can't be going in different directions to be an equivalent vector. So M and N are equal to one another because they are the same length, same magnitude, and they're both going in the same direction. How do I know if they have the same magnitude? Then you need to use your formula and plug it into the distance formula for magnitude and make sure you get the exact same thing. Now, with opposite vectors, they have to have the same magnitude. Remember, use your distance formula to find magnitude. But they will have opposite directions. U and V, vector U, vector V, they are going in opposite directions. This one's pointing to the right, this one's pointing to the left. However, they are the same length. So if you have opposite vectors, you could say U is equal to negative V, or V is equal to negative U. Opposites are a change of sign, okay? All right, so what I want you to do is 5, 6, 7, 8, and 9. You're going to take these and you're going to classify them as parallel, equivalent, opposite, or you could even say none, okay? So you might have a vector that doesn't have any of these three properties, and that's okay. All right, now when you do number 5, you have A and E. Vector A is found right here, and vector E is found right here. This is a C, not an E, y'all. So A and E. Figure out if they're parallel, equivalent, opposite, or none. Okay, so that is going to be the second part of your assignment, number 2, 3, and 4, and then 5 through 9. So 5, 6, 7, 8, and 9. All right, so now let's look at this next section. To prove or show that two vectors are equivalent, they have to have the same magnitude, so you'll use your distance formula, and they also have to have the same direction. Okay, to prove that they have the same direction, use your slope formula. All right. So, looking at number 10, you've got vector AB, terminal, or initial and terminal, and vector CD, initial and terminal. All right, be very careful with those. All right, and first thing that you want to do is you want to find the magnitude of vector AB, then find the magnitude of vector CD, then find the slope of AB and the slope of CD. Okay, if your magnitudes are the same and if your slopes are the same, then you can say that you have equivalent vectors. So with that being the case, I also want you to do number 10 and number 11. All right, so work these problems out, send them to me, and y'all have a great day.